So let's continue talking about this here. So in the previous cases, right, A was 1. In some cases, A is not 1. And the way you check whether A is 1 or A is not 1 is going to be, well, can you common factor it? So obviously the first thing here that you notice, right, with the value here is that A is not 1. It's 3. So this is a kind of unique case. I'll rewrite this here. So don't worry, we're going to ignore that there. So what we're going to be doing is first check for a common factor. Can I common factor out the 3? Because if so, my life would be a lot easier. And the answer here is no. I cannot common factor out the 3. Right? So that's a little bit of an issue. If we can't common factor out the 3, what do we do? Right? How do we figure that out? And so what happens here with this is that, okay, let's write down our A, B, C, and A times C. So A is 3, B is 14, C is 8, and we write down A times C. So 3 times 8 is 24. So now the issue here, the slight difference here, is that we need to think of two numbers that add to 14 but multiply to 3 times 8, which is 24. So two numbers, can anyone think of two numbers that multiply to 24 but add to 14? 12 and 2. Very good. 12 and 2. Okay. So this one works a little bit differently. So we're going to write the two numbers down, 12 and 2, but we don't put them in the brackets right away. And the reason why we don't put them in the brackets right away is because we still have this 3 that we're talking about in the front. We have to make sure that if we do x times x plus 12 and x plus 2, don't write this down. If we do this, if we do x times x, that's not going to give us 3x squared. That's going to give us x squared. So we do have to change the method that we're doing if a is not 1. So what we're going to be doing instead, once we have the two numbers, what we're going to do is write it out and kind of expand this middle part into two pieces, which are the two numbers we're going to be working with. So essentially, this is what happens. So using these two numbers, we're going to get 3x squared, and I'll write this in red, plus 12x plus 2x plus, and then plus 8. So notice how I've changed the 14 into 12x plus 2x. So I've taken my two numbers and I've split it up like this. Okay? So 3x squared plus 12x plus 2x plus 8. So we have that there. Once we have that down, okay, we're going to now common factor this into two sections. We're going to split it right down the middle like this. Just split it right down the middle. Okay? And you're going to common factor it up. And so for my first part, I would get 3 times, 3x, and then we're left with x plus 4. And on the right side, we would get factor out 2, and we get x plus 4. So you common factor by splitting this into two sections. Section 1 on the left, and then from the right, section 2. Once you do that, you'll notice that it factors out the same bracket in each case. And we talked about this in our first lesson, yesterday's lesson, where when we have the brackets the same, those get common factored out. So then what happens is we get x plus 4, and we write down whatever's left over, which is the 3x plus 2, into a second bracket, and this is going to be your final factored form. Okay? So a lot more quote-unquote complicated, just because A is not 1, right?
Mr.
This
Choi,
becomes the biggest issue. Yes.
is it okay if we write it in the other way, like 3x plus 2 first before?
Yes, that's fine. Yep. That is absolutely fine. You can write 3x plus 2 and then times x plus 4. That is correct. So the order of the brackets doesn't matter, because when you FOIL it, you should still get the same answer. Okay. So this is your product and sum method, right? Where there's still two more methods to go. There's the Australian method, and then there's the fraction method, or as I call it, Mr. Choi's method. Some of my students from last year will know Mr. Choi's method and maybe remember it once I kind of go over it. You can pick whichever one you want. I will never say use this, use that. When it comes to factoring, you just have to use the one that you are most comfortable with, and as long as you can do it well, that's all that matters to me, right? The end goal is the same. Is it factored? Right? If you can factor it and it's the exact same, right, and it's the correct factoring, why would I get upset? So make sure you pick one or learn all three if you want to, but use the one that's most comfortable for you. If you're working on a test, the first thing that comes into your head should be the one that you're using. Not, oh, Mr. Choi said this is faster, so I should use that. No, that's the wrong way to take it, right? Or my friends use this one because it's faster for them, so I'm going to learn that one. I'm like, no, you're not your friend, and you're not me, right? Use the method that's most comfortable for you and the one that your brain goes to as a first kind of choice. That's the one you should be using for tests or assignments or stuff like that, okay? So let's talk about this one here, factoring trinomials using the Australian method. So the Australian method is a little bit unique. You still have to think of two numbers that are add and subtract to b and a times c. But the way you set it up is a little bit different. So here, let's look at question A here. 3x squared plus 4x minus 4. We're going to write down what is A, 3, what is B, 4, what is C, negative 4, and what is A times C? Well, 3 times negative 4 is negative 12. So the beginning to all three of these methods are the same, which means if I don't see you write this out or you haven't done this, that's when I get upset. I'm like, you should at least do that. Write down what you know. Write down your givens. So first figure out what is A times C and what is B. Then think of two numbers. What are two numbers that multiply to negative 12 but add to 4? Christian typing out negative 6 and 2. Perfect. That is correct. So we're going to get negative 6 and 2. Oh, sorry. Hold on. Sorry. Positive 6 and negative 2. Sorry. Because the 4 is positive. The bigger number, if you guys ever get confused, sorry, to kind of answer the question, if you want to figure out the sign, which one gets a negative, which one gets a positive, the bigger number gets whatever sign the b value is. So since the b value is positive, the 6 is the bigger number, that will be positive. That's another way you can kind of figure out the signs really quickly. So once we have our two numbers, this is how it's going to work. What you do first is you take the a value of your equation, and we're going to just kind of write out two brackets using the a value like this and divided by the a value. Like that. So we're literally just writing 3x over 3. What we're going to do after that, I should write this a little smaller, but I'm going to zoom in a little more so I can write a little smaller. Sorry. And that way you guys can see it better too. So once we have that down, what we're going to do next is we're going to now add the numbers into the bracket. So we're going to add in plus 6 here. And on the other side, we're going to add minus 2. And it's still all divided by 3. Once we have that done, we are now going to common factor each of the brackets. So on the left, I'm going to common factor out a 3. And on the right side, I can't really common factor anything out, right? 3x minus 2 doesn't have any common factors, so we're just going to leave that there. And that's all divided by 3. What you'll notice now, because we factored out the 3, we can actually cancel it out. It beautifully cancels out. And so what are we left with? We're left with our two brackets, x plus 2 and 3x minus 2. And this is the Australian method. By doing this, you are able to cancel out the denominator nice and beautifully, which will leave you with the two brackets at the end. Yes, we will go over one more question because it is new. So we will do one more. Okay. So I'll leave that there. And then we're going to do one more question like this. Okay. Let's move on to the next question here. So 8x squared minus 2x minus 1. So let's write down all the values that we know. A is 8, B is negative 2, C is negative 1, and A times C is negative 8. So we write down all our values. We highlight the ones we actually care about. And then we write down the two numbers. So two numbers that multiply to negative 8, but add to negative 2. Yeah, Brooke and Lorraine saying negative 4 and 2. So those are the two numbers that we're going to be working with here. So with the Australian method, what you start off, once again, look at your A value. You're going to write two brackets of the A value like this and divide it by the A value. So everything is with the A value to start. I'm going to zoom in now. Once we have that down, we can add in our two numbers into the bracket. So we have minus 4, and we also have plus 2. And now that we have that, we are now going to common factor each bracket. So in our first bracket here, we can common factor out of 4. So we're going to factor out of 4. That leaves us with 2x minus 1. On the right side, we can factor out a 2, and that leaves us with 4x plus 1 divided by 2. Sorry, why did I write 2 here? It should be 8, sorry. That should be an 8 there. And it divides by 8. And what that nicely does, once again, 4 times 2 is 8, so these actually all cancel out. And we're left with just our brackets, 2x minus 1 and 4x plus 1. And that would be our factored form here.
Mister, where did the 2x came from again?
Factoring out the 4. Common factoring out the 4. So 8 divided by 4 is 2. So this here is the Australian method. The last one I'm going to have you do on your own, not now, in a little bit. I'm going to teach you the third method as well. Okay, so I'm going to teach you the third method, and then you guys can try some for yourself, some practice for yourself here. Okay. Method 3, using the fraction method, or as some of you and I call it, Mr. Choi's method. It's very similar. It's a similar concept to the Australian method, but instead of writing out all these fractions, like this big fraction, you actually just have to write two small fractions and kind of make your life a little bit easier. So let's look at the same equation here, right? 3x plus 4x minus 4. This is the same one as the previous method. So A is 3, B is 4, and C is negative 4. And the two numbers are going to be A times C, right? Negative 12. And we said before the two numbers from here, we said was 6 and negative 2. So that doesn't change, right? That's still from the previous question. The two numbers don't change. The difference, though, here is what you're going to be doing to set it up is you're going to write the two numbers as two separate fractions like this, and you're going to divide it with the A value. So kind of just to show you here on the next step, this would become 6 divided by 3, and then negative 2 divided by 3. Okay. What that allows us to do is then simplify the fraction. So this can simplify down. So we're going to divide the left side by 3, and that's going to give us 2 over 1 and negative 2 over 3. Right? And this is actually the two brackets. So I'm going to write it as a side note here for you to see. Okay. Each fraction is a bracket. Bottom number goes first. So to show you how that works, in the first bracket, what we have here is 1x plus 2. And in the second bracket, bottom number goes first. So it would be 3x and then minus 2, and you're done. So this is the fraction method here. Okay. So this is the third method you can use to kind of do your calculations here to figure out what the brackets are. And is that the same answer as we got in the previous question? Absolutely. Right? It's the exact same. So any method works. Method here. And then you have 2 questions to try on your own. All right. So question B here. What is our A value? Our A value is 2. Our B value is 11. And our C value is 5. And I need to reconnect my tablet because it's messing up. Okay. And our A times C value is going to be 5. Oh, sorry, not 5, 10. 5 times 2, which is 10. Once we have these two, what multiplies to 10 but adds to 11? There's really only one option. It would be 11 and 1. Right? 11 times, 10 and 1. What am I saying? I am tired this morning, as you can see. 10 and 1 is the only option. 10 plus 1 is 11. 10 times 1 is 10. My goodness. So, write those two numbers down and divide it with your A value. So instead of writing this first part, you can kind of just skip over it and just quickly divide by the A value here. Simplify the fraction. 10 over 2 can be simplified to 5 over 1. And then write the two brackets. X plus 5, 2x plus 1. And you're done. Okay? So the fraction method technically is the shortest. However, don't forget, people start to get things wrong when they forget to common factor their first equation first. Be sure you common factor or else you're going to get it wrong. Okay? So same thing goes for this last question here, like part C that you're going to try on your own. Make sure you common factor something out and then use this method or else it's going to mess you up. And I'm going to say that now. Okay? So you have 2 more questions for you to try. I know it's within, method 2 and method 3. Pick whatever method you want to use. Factor both of these. I'll give you 5 minutes to do so, and then we're going to take it up. Okay? So factor both of them. I'll give you 5 minutes. I can play some chill music if you want while we do it. But yeah, I'll give you 5 minutes. So I'll give you guys another 2 minutes. Okay. Let's take this up. So it doesn't matter what method you use for this. You could have picked your own method. I'm kind of curious to see or to hear what method you guys used. So could you type in chat which method you use by typing the number 1, 2, or 3? I'm just curious which one you guys use to kind of factor. It just gives me an idea of what you guys prefer. Most people using the Australian method. Very good. Okay. No, nice. That's really good to hear. That's good. You use the Choi method. So we have a couple people using my fraction method. We have a couple people, most people using the Australian method, and we have Sophia, and I think Sophia's using method 1, which is the product sum method. Good. We have a good range. We have at least like a couple people using one of each, right? Which is great. So let's take up each one. Remember, regardless of what method you used, right? Sorry, my video is not even on. Regardless of what method you used, it doesn't matter, right? Because at the end of the day, all that matters is that your final answer is right. Because if you got the final answer right, that means you did it right, if that makes sense. You know what I mean? So that's what we're going to be doing. Okay. So let's take that up. So here we go. For this one here, I'm just going to stick with the Australian method and method 3. So if you want to check if you did method 1 and you want me to do one of these questions doing that, just let me know in chat and I'll do method 1 as well. For now, I'm just going to do method 2 and 3. So here, writing down Can I common factor this? No. 16, 8, and 3 have nothing that's in common. So we're just going to write A is equal to 16, B is equal to 8, C is equal to negative 3, and A times C is equal to 16 times negative 3, and that's going to give me negative 48. So most people did method 2, so this should be a good check for you all. What are two numbers that multiply to negative 48 but adds to 8?
Negative 4 and 12.
Negative 4 and 12. Okay. So there's our numbers here. Now, some of you are maybe thinking, do we have to write this initial step? No, you can actually jump right into here. So to save a little bit of space, you can actually just jump right into plugging in the numbers into the bracket. As long as you have the correct form, right, this is completely fine. So I'm just going to skip that first step we wrote previously, right, to save a little bit of time, but making sure that you're still setting it up correctly. It's A, and A. Those are all there. And then you have your two numbers. So negative 4 and 12. Once we have that down, we can then factor out the brackets. So in the first one, I'll factor out a 4, which gives me 4x minus 1. On the right bracket, I'll factor out another 4, which gives me 4x plus 3. And then I divide all of that by 16. 4 times 4, the things we factored out, equals 16, so we can cross that out nice and beautifully. And what does that leave us with? And that leaves us with our two brackets, 4x minus 1 and 4x plus 3. And there we have it. Okay, so that was the Australian method. Most of you did this method, so hopefully you wrote down your steps like I did here and got your final answer. There's your two factors here. Great. Let's move on to our second question here. This one here, regardless of what method you use, please make sure you are common factoring first. I did have one person message me an answer and said, this is what I got, and I said that's incorrect. And the reason why that was incorrect is because you forgot to common factor. So, the person knows who I'm talking about. So you did the right steps, you just forgot the common factor at the beginning. All three of these numbers are divisible by 3. So you should actually have this before you start anything, which changes your A values. Your A is now 5, your B is now negative 9, your C is negative 2, and your A times C is negative 10. That's going to change your answer, right? If you don't common factor, you're going to forget. So make sure you common factor out. The two numbers that multiply to negative 10 and adds to negative 9, my apologies. Anyone know?
Negative 10 and 1.
Negative 10 and 1. Perfect. So negative 10 times 1 is negative 10. Negative 10 plus 1 is negative 9. So we're going to write those two numbers down as fractions, and we're going to divide it by A, which is 5. Then we simplify the fraction on the left, divide top and bottom by 5. We're going to get negative 2 over 1. And then we get 1 over 5. We write down the brackets. We common factored first. So this needs to come down, and you need to write it down here, right? We common factored. Whatever you common factor has to be there at the end. Then you write out the two brackets. You get x minus 2 and 5x plus 1. And that would be your final answer. Okay. Any questions? So if you don't common factor first, your answers are going to be incorrect. I'm going to zoom out so you guys can all see it in case you missed anything. If you don't common factor, your answers are going to be incorrect because right, it's going to cancel out more than it needs to, right? So it becomes a slight issue if you forget to common factor something out. So make sure you common factor first before diving into any one of these methods so that you save yourself a bit of a headache at the end, right? Remember that you can always check your work using FOIL, right? You can always check your work using FOIL, expand it out, and see if you get the same answer. If you don't, something's wrong. And just make sure you check that. Okay. Any questions about any of the methods here? Or if you're like, can you go over another question with this method? Anything in chat? Going once. Going twice. All right. I'm assuming you all are perfect geniuses in factoring now because there are no questions. So we're going to move on to why we factor. What's the point, right? A lot of you always have that question in math. What the hell is the point of factoring in the first place? What is this going to give us? What does this do for us? Which is a very valid question. Usually quadratics, we usually link it to physics, specifically science. Science and math are very like intertwined with each other, right? You can call them boyfriend, girlfriend if you really want to, right? You can't do one without the other, right? They're very intertwined. Math helps solve physics problems, and physics problems are the applications of math problems or even chemistry, so on and so forth, right? There's always going to be a connection between math and science, and the most often one, for example, what I've done in high school, when I was in high school for physics, was we had to use quadratic equations and physics, right? Our physics knowledge. We created a wooden catapult, right? And we had to fire a marble, and we had to calculate exactly where the marble dropped. Exactly where the marble dropped. And so once we kind of predicted where the marble was going to drop mathematically using a parabola and all these graphs, right? We had a huge school-wide competition where we had to tell the teachers exactly how far our marble was going to land, and there was a giant target. And if you hit the center of the target, you got 10 out of 10. And anything outside, every ring outside of it was -1. So if you failed to hit it, you got 50% on the practicality of your catapult. It was actually really fun. But the idea here is the reason why we factor, right, is that it actually tells you those landing points of your graph. More specifically, if we talked about it in mathematics terms, it's your x-intercepts. Your factors give you your x-intercepts. Where does the marble land, right? It tells you exactly where it would land, assuming like, you have all the other values required, right? So this is really important in that sense. There's just a simple application just on physics. There are other applications as well. For example, when you see arches on bridges or even like architecture, like structures, right? Old structures, you'll see arches used very often because it's stable, number one, and you need to make sure that it's a nice perfect curve and where those legs should go. Lots of different applications of these parabolas, and why we factor and do these mathematically in the first place. Okay, so just the kind of idea here. So let's kind of go into factoring this. Okay, so now let's dive into, once again, we factor it, then what? What's the point? What does that give us? Okay, so here we have our method here. Now, we learned yesterday that there was only one method to factor if A was 1. I'm here to tell you that it doesn't matter which method you use. for any of these quadratics now. Now that you've learned all three methods, the product and sum method, the Australian method, and the fraction method, right? You've learned all three. You can use one for any quadratic. Doesn't even matter that A is 1. It's still going to work. Okay? So let's get a vote. Which method should I use for this one? One, two, or three? Anyone have a specific preference?
1.
I heard 1, and I see 2s in chat. 2, 1. All right, we'll do it both ways then, since we have 2 and 1. People don't like Mr. Choi's method. So sad. All right, let's go through this. So the first method, the product and sum method, this was writing down A, B, C, and A times C. So A is 1, B is -2, C is -8, and A times C is -8. We write the two numbers that multiply to A times C, but add to B. So what multiplies to -8 but adds to -2? That would be -4. Yeah, -4 and +2. In the product sum method, if A is 1, we can jump right into the bracket and just write x minus 4 and x plus 2. Not an issue there. Okay? So that's done. That's the product sum method. Okay? The Australian method, it's gonna be the same, like A, B, C, and A times C. So the numbers are still -4 and 2. If you did the Australian method, you should be writing x minus 4, x plus 2 divided by 1. But if you divide by 1, you just get your brackets. Right? So dividing by 1 doesn't really affect anything. So the Australian method will still give you the exact same thing. And of course, Mr. Choi's method also gives you the exact same thing. If you write out these numbers here, write them as fractions over 1. And then you get your two brackets, x minus 4, x plus 2. So regardless of which method you use, product sum, right? Australian method, fraction method, you're going to get the same answer. So this is me showing you and proving to you it really doesn't matter. Okay? Now, to find the x-intercepts, right? What do we do? The factored form is great because it immediately gives you the x-intercepts. So when we look at the factored form, what you're going to do is you're going to set each bracket, we're going to call this bracket 1 and bracket 2, right? And I'll write it in text here. Set each bracket equal to 0 and solve for x. Okay? That's what you're going to be working on here. So for bracket 1, here, we're going to say x minus 4 is equal to 0. That's bracket 1. We solve for x, which gives me x equals 4. Pretty easy math, right? And then for bracket 2, x plus 2 equals 0, and that's going to be x equals -2. So we have our two x-intercepts, and we just write it. X-intercepts are 4, 0, and -2, 0. That's it. That's how you find your x-intercepts using your factored form. Set each bracket equal to 0, solve for x, there's your x-intercepts. Okay? That's all you have to do. Right? Some of you might be thinking, oh, Mr. Choi, when we were in your grade 10 class last year, you said we can just find the opposite sign of what's in the bracket. Didn't you say that? I'm like, yes, I did say that. But that's not going to be true when you have something like 3x plus 2. How do you find the opposite sign of that when there's two numbers, right? So now I'm being more specific for a general case. No matter what kind of factored form you have, if you set each bracket equal to 0, you will always get the x-intercepts when you solve for x. So you do have to do just a little bit of algebra to get your x values. Okay? So that's our x-intercepts. Then let's go one step further. In part C, I'm not going to go too far here. In part C, it asks us, hey, find the coordinates of the vertex and the axis of symmetry. Okay? So what we're going to be doing now is understanding this key fact. Number one, the parabola, the quadratics, are symmetrical, right? If you fold it in half, it should be exactly the same. If that's the case, the x-intercepts should be symmetrical, which means at the middle of the x-intercepts, right? So if we have something like this, and the graph was like this, if these are the x-intercepts, at the middle of it should be your vertex. Does that make sense? Right? Because it's symmetrical, exactly where the middle of the x-intercepts are should be where the vertex x value is. So we're going to use that to our advantage here. So what we're going to do is we're going to be using this formula. The x value of the vertex is equal to x-intercept 1 plus x-intercept 2 divided by 2, which is just the average of the two x-intercepts. So when we plug it in, x-intercept 1 was 4, x-intercept 2 was -2, and we divide that by 2. That's going to give us 2 over 2, which is equal to 1. Okay? So that gives us the x value of the vertex, which coincides to be the axis of symmetry. Therefore, axis of symmetry, people got this wrong on the test because they weren't sure what the axis of symmetry is going to be x equals 1. That's the axis of symmetry. Okay? Then what do? Solve for y vertex. Yes, I can slow down just a little bit. Absolutely. So I'll pause here for a second.
Mister, can you move a little bit up?
Yes, I can. Right here. So finding the x-intercepts from the factored form allows you to figure out then further the x value of the vertex. So once again, because it's symmetrical, the middle in between the two x-intercepts should be the x value of the vertex, which is also the axis of symmetry. That's where the vertical line of symmetry is. Okay? So once we find that, we can find the axis of symmetry, which turns out to be x equals 1. Okay? So now we're going to use this to our advantage. To solve for vertex, we're going to plug in x equals 1. So since the x value of the vertex is 1, we're going to plug it in to solve for y. And to solve for y, well, you can plug it in right into the beginning here, or you can plug it into the factored form. It doesn't matter which one you plug it into. My suggestion is to plug it into the beginning. Any ideas why? Why do you think I would say plug it into the first equation I give you rather than your factored form? Some people might say, oh, factor form's easier. Sorry.
If you factor incorrectly?
Yeah, if you factored incorrectly by accident, you're just going to make your answer even further worse, right? That's not going to be great. So my suggestion is to plug it into the beginning because that equation is right. That's the one I gave you. So I highly suggest plugging it into the beginning and then solving for y. Yes, your answer might be wrong, but at least it's still more like I can see the work and you've plugged it into the original rather than if you factored it incorrectly. So just a slight thing. So I'm going to copy down the equation here. So x squared minus 2x minus 8. So we have y is equal to x squared minus 2x minus 8. And that's when we plug it in, it's going to give us 1 squared minus 2 bracket 1 minus 8. Multiplying this out, 1 squared is 1. Negative 2 times 1 is negative 2. And then minus 8. We can then solve for the y value. 1 minus 2 minus 8 is going to give us negative 9. We can then write down our vertex. What is the vertex? 1 comma negative 9. And that would be your answer. What's great about this is you have exactly 3 points to graph it to. So if I ask you to graph it, it wouldn't be too bad, right? It's just a side note. You have your two x-intercepts, which we said was 4 and negative 2, right? 4, negative 2, and then 1, negative 9 would be like somewhere down here. And you can actually just graph it. It's like, ta-da! Super easy, super smooth, right? So being able to find factored form helps you a lot, right? You can find all the other pieces of information once you factor it, and it's able to be factored. All right, any questions here? I know I went a little bit fast. Thank you, Christian, for telling me to slow down. Remind me to slow down if it's a little too fast for you, so I can slow down and re-explain. I'm going to zoom out here. I think I was supposed to put that at the bottom. Oh, it is. Yes. Whoopsies. Sorry. I'm just going to shift this over. If you've already written it down, don't worry. This should be here. My apologies. Sorry, I'm just shifting that down. None of the notes actually change. And I'm just going to change that to here. Sorry, I'm just shifting over the order of your notes. My apologies. It's still the same. You can keep it all into one section if you'd like, but this should be able to be a little more clear for which section. That's my fault. So you can see there's a lot of work once you find factored form. You can find x value of the vertex. You can find y value of the vertex. You can find the axis of symmetry. You can graph it, right? Boom, 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 boom. Right? So you can find all of these things now that you know how to factor, or you remember how to factor. Okay? So let's take the time to practice this over the next 50 minutes. Okay? Let's take the time to practice this. So I'm going to end the live stream here, the recording of the lesson here. And then let's work as a class to kind of just solve each one, because we're going to be going like back and forth with, take some time to solve it, let's take it up. Take some time to solve it, let's take it up. So once again, final call. Any final questions before we jump into practice problems? Okay, so I'm going to end the live